Okay, today we're going to talk about density. We're going to talk about how to read mass and how to read volume, and to put them together to figure out how to work out density. So first thing we'll talk about is mass. So we're going to use triple beam balance here to balance out an object. So here we have an object on the triple beam balance, and we are going to adjust the masses here. The masses fit into these little grooves, and once the needle is balanced out to 0, all you have to do is simply add up everything, so that the way you read the triple beam balance is actually quite easy. You have these 3 arms. This is the first arm up here is in the tens. The second arm in the middle goes up by hundreds, and then you can see the bottom goes up by ones, and you can actually see the little divisions because you have 0.1, 0.2, all the way up to 0.9. And if you want to know the mass, you just simply add it all up. So in this example here, we have 500 plus 20 plus 1 looks like about 1.2. So if you add it all up, it's about 521.2. So here's another example. If we look at, for instance, in this case here, we have, make it a little bit bigger. We have, let's imagine this is it's all balanced. The needle is pointing to 0. We have an object on the scale. So how do you read this? Well, this is 70. This is 0. So that's 70. Plus 7.5, so that looks like it's about 77.5 grams, right? This example below it, sample reading 2. So again, you have an object on the scale, needle balance out to 0. You look at this, and it's 10 plus 300, so that's 310, plus about, it looks like about 0.3. So that would be 310.3. So this is how you get the mass. Okay. Now, how do you get then the volume? So the volume is going to be determined by, well, this is if it's an irregular object. If it's a regular object, we can just do some simple calculations. But if it's an irregular object like this rock here, you're going to use the displacement method. So the way you do it is you have a graduated cylinder full of water, and you record the initial volume of the water. So in this case, it looks like about 150. You drop in an object, and then the volume of water now reads about 180. So the displacement method is simply the difference between the final and the initial. So 180 minus 150 is 30 mils. So that means the volume of the rock is 30 mils. So if we look at our 2 examples here, 2 sample examples, let me just go to this slide. We have the initial volume is 30. So the initial is 30. And the final is, it looks like it's about 35. So the difference, final minus initial, is 5 mils. So that means that this rock is about 5 mils in terms of its volume. Now, if we look at another example, let's say we look at, for instance, this one, you can see the initial volume is 20 mils. And the final volume is about 30. Now, it doesn't look like, you have to read the bottom of the curve, by the way. So it's always the bottom of the curve. So it looks like it's a little bit more than 30, kind of in between 30 and 31. So I'm going to estimate about 30.5. So the volume of my rock, and this is the difference between the two, final minus initial, would be about 10.5 milliliters. Okay, so now we can put these 2 ideas together, and we could figure out then how to do the density. So the density of the object is defined as D is equal to M over V. So let's use our 2 examples from sample 1. So in sample 1, if you remember, the mass of my object was 77.5 grams, and my volume was about 5 milliliters. So if we do D equals M over V, mass over volume, we get a density of 15.5 grams per milliliter. Okay. With our second example, the mass was not 77.5, it was, if you remember, 310.3 grams, and our volume was 10.5 mils, so 10.5 milliliters. So in that case, the density is 29.6 grams per milliliter. Okay, so now let's look at, again, these are for objects with a volume that are irregular shaped objects, so you need the displacement method. But I'll show you an example of what happens if you have an object that is actually regular. Like you don't need the displacement method, for example, for a question like this one, because this is just a rectangular object. It's solid. It's got your you got your width, you got your height. I call this the length, I guess, and you got your dimensions. So here you don't need the displacement method. You could just simply figure out your volume as just length times width times height. So that would be 10 centimeters times 4 centimeters times 5 centimeters. So that would be a volume of 200 centimeters cubed. So in this case here, we can just use simple math to figure out the volume. And then again, the density is just simply the mass over the volume. So since the object has a mass of 1,100 grams, so 1,100 grams over 200 centimeters cubed equals 5.5 grams per centimeters cubed. Okay, let's actually look at two other examples where you're looking for, say, something else. We're not looking for the density, we're looking for maybe the mass or the volume. So in this case here, we're looking for the mass. So if D equals M over V, then we can rearrange and say M equals D times V. So the mass is a function of the density, which in this case is 3.5 grams per milliliter, right there, times the volume, which is 100 milliliters. So then our mass would be, if we finish it up over here, our mass is 3.5 times 100. You'll notice the milliliters cancel out. You'll just be left with grams. Our mass would be 350 grams. Okay, so there's an example of rearranging the D equals M over V to get M. In the next example, we're going to rearrange to get for V. So if D equals M over V, then V equals M over D. So in this case, we have the mass is 25 grams and the volume is 4.0 grams per milliliter. So you'll see grams cancel out. So our volume then would be 6.25 milliliters. Okay, that's it. Thanks a lot.